13 talks about, these are called the measures of central tendency. So if you ever hear anything talking about the measures of central tendency, it's talking about mean, median, mode, and range, and sometimes it's talking about standard deviation. And if we have time at the end of class, I'm going to talk to you about standard deviation. If not, we'll save it till tomorrow. So y'all know that mean means average, right? And how do you get an average? Right, you add all your data and you divide it by the number of values that you have in your data. What does median mean? Right, you got to put everything from least to greatest, right? That's important. You got to put it from least to greatest. And it's the number in the middle. That's if you have an odd amount of data. What do you have to do if you have an even amount of data? You take the average of the two in the middle, right? Okay, what's a mode? It's the one you see the most. Do you always have a mode? No. Can you have two modes? Yes, they can tie for the most often, okay? And your range is your highest to your lowest number, all right? So to start with, for an example, here's some data, and we want to find all four of those. All four of them. I'm going to find a calculator in the meantime. While y'all are writing it down. All right, are these in order? No. So I'm going to put them in order because I'm going to have to find a median as one of mine, okay? So what's my lowest term of that data? 13. And I like to mark them out as I do them so that way I don't skip anything. What's my next one? Then what? How many 19s do I have? Just two. Okay, then what? 20. Then what? 21, and then 22. 25, 30, 31. All right. So how many do we have? How many are there? There's 10 total, okay? So if I'm finding the mean, how do I do that? I'm going to add them up and divide by 10. So y'all add with me and we'll see if we get the same number. So everybody add these in their calculator and we'll make sure we get the same number before we continue. What'd y'all get? 216 divided by 10 means I move one decimal place, doesn't it? So that's 21.6. So there's my mean, 21.6. Let's get our median now. What does median mean? The number in the middle. But I have 10 of them, so I'm going to have two numbers in the middle, right? What two numbers are in the middle? 20 and 21. So I take the average of those, which means I add them together and divide by 2. So that's 41 divided by 2, 20.5, 20 and a half. Y'all can give me decimals today. Just saying. I'm giving you permission ahead of time. All right, let's find the mode. What does mode mean? The one you see the most often. Do we have one that is repeated? 19. It's the only one that's repeated, right? So the mode is 19. And the last is the range. What does range mean? Highest minus lowest. So 31 minus 13 equals what? 18. Very good. A lot of times your mean and your median are close to each other, but not always. Just depends on how skewed your data is. A lot of times the mean and the median will be close if your data is spread out evenly. All right, any questions about those four central tendencies? Y'all know how to do those? All right, that's the end of section 13.6. Not really. All right, section 13.7, we're going to talk about stem and leaf plots and histograms. Stem and leaf plots and histograms. Does anybody remember what a stem and leaf plot looks like? Have y'all seen one before? It looks like a T-chart. Looks like a T-chart. But yeah, you got one side called your stem. You remembered. And another side called your leaf. Good job. So y'all write down those. I'll let you write down all those numbers before I get started. Don't y'all wish y'all all had like an iPad or something and I could just download these to you? Because we don't have a laptop or an iPad for everybody. Yeah, but this program is not really compatible with that. I'd have to download it as a PDF. If I did everything electronically, what would be the purpose of me standing in front of y'all every day? I would lose all of my joy in my life.
You can tell us more about your life.
Do that anyway. I give y'all TMI already. All right, so like Peyton was telling us, we got stems on the left side. And we got leaves over here. And the leaf side is kind of longer. And for your stems, you kind of look at how many digits you have. You could have decimals, okay? But you want to pick the left-hand digit that you have the most often. And it looks like most of these are either single digits or they're in the teens, the 20s, the 30s, and I think I see a 40s, right? So the tens place would be a good stem to have. But what will we do for our single digits for their stem, do you think? 0. We can use 0 for a stem. So I have single digits, teens, 20s, 30s, and I have 40, maybe 50s. No. So 44 is my biggest stem I need. And when you're doing a stem and leaf plot, you find, like, for example, we're going to start with all of our single digits. We're going to put them in order from least to greatest. If it repeats it, we repeat it. And we do not use commas. We space them out. Okay? That's kind of controversial. Sometimes some books use commas and some teachers use commas and some don't. I'm saying don't use a comma. Just space them out. So I'm going to highlight all my single digit numbers. I got 8, 8, 7, 3, 4, and that's it, right? So what is my lowest of those single digits? 3. And spacing them out. And then a 7, and then an 8, and an 8. Is that all of them? Is that all of them? All right, so I'm going to do all my teens next. That's all of them with a 1 in front of them. I'm going to highlight those green. So I've got 14, 19, 18, 14, 15, 12. So what's my lowest one of those? 12. Whoops. And then what? 14. And 2 14s, right? And then 15. And then 18 and 19. Is that all of them? All right, I'm going to highlight my 20s in blue. I've got 25, 23. That's it, right? I'll put a 3 and a 5. I'm going to do my 30s. I can just look at what's not highlighted, right? I got 33, 37, 39. So 3, 7, and 9 for my 30s. And my last one for my 40s is 42. Now I'm almost done. Okay. If you have a stem and leaf plot, you also need a key. Now, a key just tells you what those numbers mean. So I would just make an example from this. 4/2 means what number? 42. Okay. So you need a key to tell me what that means. Because this could, if I just see the stem and leaf plot, that could mean 42, or it could mean 4.2, or it could mean 4,200,000, or it could mean 4,200, or it could mean 0.000042. Okay? So you need, that's what a key does, is it tells you what place value that means. Does that make sense? Okay. Bless you. This is a double stem and leaf plot. You don't have to write this down, but I just want you to see it. Apparently I couldn't write the word when I wrote that. That's not much better. But anyway, this is a double stem and leaf plot. They're comparing boys and girls' ages or something like that. And so they've got the stems down the center, and they're just branching off both ways. So you can do a double stem and leaf plot like that if you're comparing two different things. Does that make sense? So from this is all my boy data and my girl data. And I can find averages on this side for the girls and averages and means and medians on this side for the boys. Does that make sense? So that's a double stem and leaf plot. Just wanted y'all to see one of those. Histograms. Histograms look at frequency of data. Now, what does that word frequency mean? How often something takes place. Okay? Frequency is how often something happens. So, this example is, I have listed, I haven't, but there's an example of a listing of test grades for a particular test that a teacher gave. And we want to find ranges for our data. So I think what this teacher did is they broke it up of who made in the 60s, who made in the 70s, who made in the 80s, and who made in the 90s. I don't think anybody made 100 on this test. Okay, so the teachers want to look at her data, his data, whomever, and to see how many of them made in the 60s, how many made in the 70s, how many made in the 80s, how many made in the 90s. I kind of do something like this when I look at y'all's test grades, but I do it based on A's, B's, C's, D's, and F's. How many of my kids made an A? How many made a B? How many made a C? Does that make sense? And I'm hoping that most of y'all made A's and B's, right? If most of you made A's and B's, then I say for the majority, most of us understood the material. That's just my own personal scale. But this teacher wants to classify it by 60s, 70s, 80s, and 90s. So this would be college A's, B's, and C's, right? So you need to I use tally marks. So you got to come up with your ranges, and sometimes that's the hardest part, is coming up with your ranges. So for this one, the ranges are 60 to 69, 70 to 79, 80 to 89, and then 90 to 99. So what we're going to do is we're going to go through the data in order that it's in already, and I'm going to mark with a tally mark which category that fits into. Okay, so 71 is in the 70s, 85 is in the 80s, 86 is in the 80s, 89 is in the 80s, 95 is in the 90s. Y'all see what I'm doing? 72 is in the 70s, 83 is in the 80s, 63 is in the 60s, 98 is in the 90s, 97 is in the 90s, 87 is in the 80s, 78 is in the 70s, 80 is in the 80s, 73 is in the 70s, 64 is in the 60s. Now, how could I double check and make sure I haven't missed something? Count my numbers and count my tallies, right? I'm going to do that real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Apparently I got them all. Okay, so a histogram, then you make a graph of your data. And so we've got the ranges across the bottom. Those are our test grades. And then the number of students who made those scores on the vertical axis. So how many students made in the 60s? 2. So I go up to 2 and draw a bar. So it's kind of like a bar graph, but not really. And also histograms need to be touching from one bar to the next. Okay? And then in the 70s, how many students made in the 70s? 4. So I make my bars touch. Go up to 4. How many made in the 80s? 6. Oops. One's not very even. And then how many made in the 90s? 3. Okay. So if passing is a 70 or above, did most of the students pass the test? Yes. Another question they could ask is if the teacher wanted most of the class to make an 80 or above, did she accomplish that? How could you tell? Okay, so over here we have 4 and we have 2, so 6 students made below 80, right? And this one is 6 and 3, which is 9. 9 students made above 80. So did more make above 80 than below 80? Yes. Okay, so there's a lot of different things we can ask about data from a histogram. Does that make sense? Does that make sense? Okay. Good deal. So there's a histogram. So that talks about frequency of data, how many times something occurs. Like I said, the tricky thing about a histogram is coming up with the ranges. Have y'all seen a histogram before? Good. Like I said, this is junior high math today. All right, everyone's favorite. Section 13.8, box and whisker plots. Now, these have been on your state test before, and these have also been on practice tests. Okay? I've never seen a real test, so I don't know if it's on real tests, but they have been before. And I know they're on practice tests. So we need to talk about box and whisker plots today. Can y'all remember anything about box and whisker plots? What do you remember? What did it look like? Yeah, it's got a rectangle and then 2 lines coming off the rectangle, right? Thus the name box and whiskers. Right? So a box and whisker plot helps you look at quartiles of data. Now, a quartile, they must have let out of a project. Anyway, one might be the one next door is probably over. Okay, so what a quartile is sectioning off the data in 25% increments. So we'll see 25% in one area, 25 in another area, 25% of your data in one area, and 25 in the last area. So it's breaking everything up in 25% sections of data. All right, it's all based off of medians. Medians. So if I'm dealing with medians, what does the word median mean? Middle numbers. So that means I have to do what with our data? Yes. Anytime you do box and whisker, you have to have your data in least to greatest. All right? So that's the first thing we're going to do here. So what's our lowest number? 15. And then 20. And then 25. And then 30. 40. 55. 60 and 70. Very quick count. All right, this one has an even amount of data, so we're going to have to do a little bit of work to do our median. If this was an odd amount of data, I would look for the middle number, and that would be my median. But this one has two numbers in the middle, right? What two numbers are in the middle? 30 and 40. So my median is actually right here between those two numbers. So for my median, I take 30 and 40 and find their mean, which is going to be 70 over 2, which is what? 35 is the median of all my data. All right, now to get the edge of my box, I've got to find my first and second quartiles. Okay? The way I do that is I find the median of the first half of the data for quartile 1, and for the other quartile, I find the median of the second half of the data. So my middle of my data was between 30 and 40, right? So I have 4 numbers to the left of that. So which 2 of those are in the middle? 20 and 25. So my Q1 is going to be 20 plus 25 divided by 2, which is 45 divided by 2, which is what number? 22 and a half, 22.5. Everybody good with that? And then my second quartile is going to come from my median of the second half of the data. So that means I'm averaging what two numbers? 55 and 60. 55 plus 60 divided by 2. What's 55 plus 60? And what's 115 divided by 2? 57.5? All right. Once I have those three numbers, the median, my Q1, Q2, you're ready to draw your box and whisker plot. Now, when you do that, you've got to make a number line. And then you decide how you want to label your number line. I'm not going to go by single digits because it's going to take me forever to go between 15 and 70, right? So you could go by 5s, 2s, 10s. I'm going to go by 5s because I think going by 10s will get them. I don't think I'll have enough numbers. So I'm going to go by 5s. So my lowest number is 15. You can start there. 15, 20, 30, 35, 40, 45, 50, 55. Go a little longer. And try to keep them evenly spaced. I know I don't do a good job of that. 60, 65. Go a little bit more. 70. You probably could have go by 10s on this one and be just fine. And I'm going by 5s. So when I'm putting these on a number line, we're going to have to kind of estimate where they are because not all of these are in increments of 5 with our data. So the 3 numbers you need. To make your box, you need these 2 numbers. I did not mean to do that. Highlight. You're going to need these two numbers to make your box. Okay, so that makes your left side and your right side of your box. So 22.5 is halfway between 20 and 25. So that's going to be the left end of my box. Now, when you draw your box, you don't put it on the number line. You put it either on top of it or above it. That's the same thing. On top of it or below it. You don't put it on exactly on top, not touching your number line. Oh, Lord. 22.5. There's one edge of my box. And my other edge of my box is at 57.5, which is halfway between 55 and 60. All right, then you draw a rectangle with those two. Oops, mine's not very straight. Y'all know my drawing is the best. Just wait until you have me for geometry if you do, and you'll really laugh. All right, now what did we do with our median? Do y'all remember? Right, that line goes inside the box. So the median does not have to be in the dead center of the box. It can be anywhere as long as it's inside the box, and it is. 35 is right here. Okay? So this longer side of our box just means the data is more spread out in this quartile. That's all it means. Do y'all remember how to get the whiskers? It's your highest and your lowest numbers. That's right. So your whiskers come from 15 and 70. So what you're going to do is you're going to go to 15 and put a dot. And then connect that to your box with a line. Same thing with 70. And connect that to a line with a box. Box and whisker. That's it. It takes a while. But after we get through explaining them, it don't take near as much. Also, if you have an odd amount of data, it's a whole lot simpler because you don't have to find the averages of your means or your medians. So let's just talk about this. So 25% of our data happens here. 25% of our data happens here. 25% of our data is here, and 25% of our data is here. So, if I ask a question like, what percent of the data is above 22.5? The answer is what? Above 22.5. What percent of the data is above 22.5? 25 plus 25 plus 25 is 75. What percent of the data is below 70? Well, except for, I should say less than or equal to, right? What percent of the data is above 35? 50. Okay, so they could ask you questions like that. Let's do another example of box and whiskers because I think this is the most complicated of the things we've done today. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, odd amount of data, so it's a little bit. What's the first thing you should do every time you go to work a box and whisker? Least to greatest every single time. So if y'all don't even want to copy it this way, want to just copy it least to greatest, that's fine. So my lowest ones are what? 0, and then what? 0, and then the cross out. 0, 0, 1, 2, 3, 6, 6, 7, 7, 7, 8. Right? 6, 6, 7, 7, 7, 8. What's the mode of that data then? 7. Did I get them all? All 11 of them? All right, so what do we have to find when we're doing box and whiskers? Okay, our median of all the data, which is the one in the middle, and this is odd amount of data, so we should be able to go straight to a number. So which one would it be? The first 6 or the second 6? The first 6. There's our median. Is everybody okay with that? Because it's got 5 numbers on the left and 5 numbers on the right. All right, so then we want to find our Q1, which is going to be the median of the first half of the data. So I've got 0, 0, 1, 2, 3. What is the one in the middle? 1. See, it's so much easier when there's an odd amount of data. Q2. They actually call this Q3. Which one's in the middle of the second half of the data? The middle 7, right? All right. Are we good on my quartiles? All right. So then we make a number line. And I'm just going to do single digits 0 to 8. I'm going to skip it down a little bit. Single digits 0 to 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. And have a little space. I'll put a 9 and a 10 down there. Just try to keep them evenly spaced or your boxes will look skewed. Like I said, I know I stink at that myself. Because I have like big gaps over here and then I have like teeny gaps over there. All right, which two numbers make my box? Right, your two quartiles. So 1 and a 7. And then we make big rectangle. Where do we get our line inside the rectangle from? The median, which is what? 6. So this one, the median is to the right side. You know why? Because a lot of these numbers at the end are repeated, right? Because I have 2 6s, 3 7s, and an 8. Okay, so that's why the median is like so far over, is because it's halfway through my data, but I have so many of them repeated, so it's kind of skewed on that side. And then how do I make my whiskers? Highest and lowest. Put a dot and connect it to the box. Questions? And we got a big long rectangle because there's a big gap in the numbers between the first quartile and the median. All right, I want y'all to try one on your own, actually. Let me count my data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 again. So you could do these by tens if you want to when you're making your number line. Let me read them to you, Peyton. In about 5 minutes. But I want you to do it now. I skipped here and I skipped the definition of an outlier. I apologize. So if when you finish your box and whisker, please write down the definition to outlier if you haven't already. We'll talk about that in a second. Good job. All right, did I get mine in order correctly? All right, so what did y'all get for the median? I'm saying the wrong word. The median of the data, the one in the middle. Did everybody get that? All right, so 36. What did you get for your Q1? 24. The first half. What did you get from the median of the second half? 45. Did y'all get those three numbers? Did y'all go by fives or tens or what? I figure you did. So 20 to 70, I guess. 20, 30, 40, 50, 60, 70, and I got room, so I'll stick at 80 on there. All right, so what numbers make up your box? So we just kind of estimate where those are, right? So 24 is almost halfway between 20 and 30, and 45 is halfway between 40 and 50, right? And then your median goes inside the box. So 36 is about right here, right? And then how do you make your whiskers? Highest number and lowest number. So 20 and 64. And then 64 is about right there. Now, what do you notice about one of your whiskers? It's way longer than the other. That means 60 is really far away kind of from the rest of the data. It's really far away from the median. So we would say that it's not 60, it's 64. So we would say 64 is an outlier. So when you're doing box and whiskers and you have one number that's far away from the rest of them, then that would be an outlier. It kind of skews our data. Then you don't have an outlier. So if your whiskers are about close to the same length, then you don't have an outlier. Even if they are both really long, if they're about the same length, it's not an outlier. Does that make sense? So that would be like me grading your quizzes that I haven't graded yet. And most of y'all are making the 70s, 80s, 90s, and then somebody makes a 47. That would be an outlier, right? What do you think that? I haven't graded them yet. I said, no judgment. It could be me that made that 47. All right, could be my key completers. I didn't.
No, I said everybody.
Well, I don't, whatever. Anyways, so what do you think that outlier is going to do to the class average for that test grade? Yes. So, okay, conversely, what if people are all, I mean, outliers don't have to be super far away, but what if most of y'all are making B's and C's on a quiz and somebody makes 110? That could also be an outlier in that direction that brings the class average up. Does that make sense? So, sometimes when you're looking at a whole lot of data, what people do is they throw out any outliers. Right? If you're looking at data and you see it not fitting the model that you want it to do, sometimes we throw out outliers. If we're looking at that, I mean, it could be just like, well, somebody had to stop the test because they left sick in the middle of it. Or, you know what I mean? There could be multiple reasons to where you could have an outlier. So sometimes outliers are thrown out when you're looking at big, huge pieces of data. So any questions on anything we've covered today? We've covered a lot. We've covered central tendencies, which is mean, median, mode, and range. We've covered box and whiskers, stem and leaf, and histograms. So any questions on any of those? All right, so that's the end of today's lessons. Have a good day.